There is a funny result hiding inside modern RAG systems. Sometimes the smarter-looking system is worse because it is allowed to be too clever. A recent paper called BM25 Wins at Scale compares several retrieval-augmented generation strategies: dense retrieval, graph RAG, raw file system agents, and plain old BM25, the lexical search algorithm that has been around for decades. And the headline is uncomfortable. At small corpus sizes, an agent that searches through files can look strong, but as the corpus grows, that agent starts to collapse. Around 10 million corpus tokens, BM25 overtakes it. At full scale, BM25 is nearly 20 points ahead. The point is not that agents are useless. The point is more precise. An agent should not be responsible for discovering the entire search space from scratch. Rank first, reason second. RAG sounds like one technique, but in production, it is really a design space. You have lexical retrieval, where the system searches for exact or near-exact word matches. BM25 lives here. You have dense retrieval, where text is embedded into vectors, and the system searches by semantic similarity. You have graph-based RAG, where an indexer tries to extract entities and relationships before query time. And now you have agentic search, where an LLM uses tools to inspect files, run searches, read snippets, and decide what to try next. The agentic version feels more intelligent. It can decompose a question. It can search again when the first result looks wrong. It can follow trails. So it is tempting to treat it as the replacement for retrieval. But retrieval has a job that reasoning alone does not solve. It has to find the right candidate evidence inside a growing haystack. The nice thing about this paper is that it does not just compare systems at one arbitrary corpus size. The authors build a ladder of 28 strictly nested corpus tiers. The corpus grows by roughly 450 times. But the question set, the relevant evidence, and the adversarial distractors stay fixed. They also hold the reader model and judging protocol fixed. That matters because RAG papers are often hard to compare. One system gets a different corpus. Another gets a different reader. Another uses different questions. Here, the question is narrower and cleaner. What happens to each retrieval paradigm as the same workload is buried under more background documents? This setup reveals a scaling effect, not just a leaderboard result. At the smallest shared tiers, the file system agent can lead. That makes sense. If the corpus is small enough, an LLM can poke around, inspect files, follow local clues, and still cover enough of the space. But the cost is already high. At the bedrock tier, the raw file agent uses 39 times more query tokens than BM25. Later, that grows to about 60 times more. It is spending reasoning tokens on discovery. As the corpus grows, local exploration stops scaling. The agent cannot inspect enough branches. It starts missing the right evidence. BM25, meanwhile, does one boring thing very well. It globally ranks the corpus against the query. The curves cross around 10 million corpus tokens. From there, BM25 leads at every larger shared tier. At full scale, the margin approaches 20 points. This is not magic. It is about the kind of information enterprise questions often contain. Real internal questions are full of lexical anchors. Product names, project names, error strings, ticket IDs, policy terms, function names, customer names, dates, and weird exact phrases that only appear in a few places. Dense retrieval can find semantic neighbors. That is useful when the wording differs. But it can also retrieve documents that are semantically similar and factually wrong. Agentic search can reason, but it still has to choose where to look. If the first few trails are bad, it wastes calls. BM25 is crude, but crude in the right direction. It takes the exact terms seriously. It globally ranks candidates before the LLM starts reading. In a large corpus with precise anchors and adversarial distractors, that is not a weakness. That is the signal. The paper also gives a useful warning about two other instincts. First, dense retrieval is efficient, but in this benchmark it is less accurate. That does not mean embeddings are bad. It means semantic similarity is not the same as evidence discovery. If the answer depends on exact grounded facts, nearest neighbor meaning can be too soft. Second, graph RAG can be powerful, but the construction cost can become the bottleneck. Some graph systems need LLM calls across the corpus to extract entities and relationships. In the paper's scaling analysis, LightRAG extrapolates to around 102 billion construction tokens, at full scale roughly 4 instance years in their estimate. MS GraphRAG also hits a large build cost wall. So the production question is not, is GraphRAG cool? It is, does this graph pay for itself at the corpus size and question mix I actually have? The strongest result in the paper is not just BM25 beating the raw file agent, it is the control where they combine the two. They keep the agent style, but replace raw file tree exploration with BM25, ranked candidate discovery. At full scale, native BM25 scores 54.8 in the matched control. The raw file system agent scores 36.9. Agent plus BM25 scores 69.4. That is the architecture hiding in the result. Agency helps after retrieval has narrowed the world. The agent can compare evidence, handle ambiguity, synthesize across documents, and decide when an answer is unsupported. But making the agent discover the entire corpus by sequential exploration is the wrong abstraction. It burns tokens where an index should be doing work. The practical rule is simple. If your RAG system cannot beat BM25, it is not production ready yet. That does not mean the final system should be only BM25. A strong architecture might combine lexical retrieval, dense retrieval, re-ranking, graph structure for the right domains, and agentic reasoning on top. But the order matters. Do not start with an agent wandering through a file system and call that retrieval. Start with global candidate discovery. Measure it against a boring baseline. Then let the agent reason over the candidates. The future of RAG is not agents instead of search. It is agents that know when to let search do its job.